Okay. Okay, now here actually we move to a different topic, maximizing utility and the law of demand. What is the relationship between maximizing utility, that is, a person is, is in the situation where you have consumer equilibrium and the law of demand. So, of course, the most important thing that we have to know is that maximizing utility is always consistent with the law of demand. You remember, the law of demand says the higher the price of a good or a service, the lower is the quantity demanded, ceteris paribus. Now, we're going to see here the relationship between utility maximization and the law of demand. Here, saying that let's say that a person, of course, a consumer, is currently in equilibrium where he is consuming two goods, avocados and, of course, tomatoes, where A stands for avocados and T stands for tomatoes. So this is the condition for consumer equilibrium, where you have equal marginal utility per dollar for all goods. We have two goods here, avocado and tomatoes. So this is here the equality sign between marginal utility per dollar or per price for avocado is equal to the marginal utility of tomato per price. So the equality of the marginal utility per dollar for these two goods indicate that the consumer is in equilibrium. What that means, the consumer is in equilibrium. So when we have this condition, we say that the consumer is in equilibrium. When he is in equilibrium, it means he is maximizing his total utility. So whenever we see that condition here, marginal utility per dollar is the same for all goods, it means that the consumer is in equilibrium, which means that he or she is maximizing his or her total utility. Now, suddenly, let's say, for instance, something happens that the price of avocado, decreases. Suppose the price of avocado decreases. When the price of avocado decreases, remember that when the price of avocado, one of the goods, decreases, it means the inequality that we have will change to inequality, which implies that because the price decreases here, price of avocado, what happens? This equality, it changes, to this inequality. Well, it's clear? Now, when this equality changes this inequality to this inequality, it means that the consumer is not anymore in equilibrium, which means that he is not maximizing his total utility. So what happens? In order to restore equilibrium, to go back to equilibrium, the consumer must do something. Because the price of avocado decreases, in order to restore equilibrium, he should increase his consumption of avocado. So when he increases his consumption of avocado, because the price of avocado decreases, what happens here? Remember that more consumption of a good means that the marginal utility of that good will go down. So when he increases the consumption of avocado, because the price of avocado goes down, it means the marginal utility of avocado will go down, and it will continue to go down until equilibrium, of course, go back until equilibrium is reinstated. Okay, so when he of course increases the consumption of avocado, the marginal utility of avocado will decrease. So the marginal utility will decrease until what? This, side of the inequality will become equal to this side. Therefore, this inequality will go back to equality, and then equilibrium is restored, and therefore he will go back to equilibrium, and therefore he will maximize again his total utility. So this, question shows us that maximizing total utility is consistent with the law of demand. The law of demand is very clear. When the price it changes, the quantity demanded will change. When the price decreases, the quantity demanded of the good increases. So this is what we did. The price of avocado decreases, the quantity demand of avocado increases. As a result of the increase in the quantity demand of avocado, the marginal utility of avocado will go down. It will continue to go down until equality is restored. And therefore, when equality is restored, that means we are back to maximizing total utility. So this shows that maximizing total utility is always consistent with the law of demand. Now, we move to another topic, the budget equation. Of course, the budget equation starts with the fact that expenditure is equal to income. Expenditure is equal to price times quantity. So if we're talking about XY plane, that means two goods, good X and good Y. Good X, we're gonna label it along the X-axis, and good Y is going to be labeled along the Y-axis. So the expenditure on good X and good Y is what? Is equal price of good X times the quantity of good X plus price of good Y times the quantity of good Y, as you can see over here. That is the expenditure. Price of good X times quantity of good X, or we could say here, instead of Q, we say the X here. Okay, let's be consistent with that. So price of X times X, let's say, times X, okay. Price of X times X plus price of Y times Y. This is the expenditure, which means that price of good X times what? Times quantity of X, where X, refers to quantity, plus the price of good Y times quantity of good Y. Now, let I stands for income, I, income. So here we say budget constraint or budget line is expenditure equal income. This is the expenditure. We put them together, PXX plus BYY equal income. So this is here the budget, budget line. This is the equation of the budget line, where PX is the price of good X, PY is the price of good Y. Great. Y is the quantity of good Y, and X is the quantity of good X. Great. Now, of course, solving the budget equation for Y, because Y is along the vertical axis and X is along the horizontal axis. So let me solve it, remember the equation of a straight line. Y is a function of X. So here I do the same thing because we have a straight line. We have a line, we have a budget line. So I solve it for Y in terms of X. So I do that one here, just simplifying this equation. I come up with this Y, this is here. This is Y equal I, the income over PY, plus PX over PY times X. As you can see, this is the equation of the budget line. This is the slope. PX over PY is the slope, okay? Here, of course, here negative, of course. Negative, of course. Now, this is, from here, as you can see, Y, equation of Y is equal I over PY minus PX over PY times X, where PX over PY is the slope, of course, because the straight line is downward sloping, because then it has a negative slope. PX over PY is the slope of this budget line. I over PY is the Y-intercept. So here we can graph it easily. Of course, we can graph it easily over here. Okay, so I over PY is the Y-intercept. and I over px is the x-intercept, okay? Where px over py is slope of the budget equation, I over py is the y-intercept, and y over px is the x-intercept. So actually you're going to have something like this, you know, something like this here. This is x, this is y, and what you see, this is here I over px, and here I over py. This is the y-intercept, okay, and this is the x-intercept, okay? As you can see, the budget line is downward sloping. I over py is the y-intercept, and I over px is the x-intercept. Now, of course, example, graph the following budget constraint or budget line. Given income equal 100, price of x equal 10, price of y equal 20. So, solution, of course, the budget equation, budget constraint, which is expenditure equal income. Px, which is 10, 10x plus 20y equal 100. So, 20y is equal 100 minus 10x. I just solved this like I did over here. Okay, solve it for y. I come up with y equal 5. You know, after simplifying this, I get y is equal 5 minus 1/2 x. So here the slope is equal minus 1/2, and the y-intercept is equal 5. Okay, y-intercept is equal what? 5, which is here, 5, which is income over the price of y. The same thing, x-intercept is equal I over px, which is equal what? I is 100, px over 10, we come up with what? With 10. Okay, so this is x-intercept. Just plug it in the formula. The x-intercept is the income over the price of x. The y-intercept is the income over the price of y, and this is what you get. This is how we, you know, do that. Okay, now remember that this budget line, of course, a change in the income can affect the budget line. Okay, so a change in income affects the budget line. PL, budget line, PL. Thus, an increase in income, what happens? An increase in income while the prices of X and Y are the same, then it will cause the budget line to shift outward in a parallel fashion. As you can see over here. This is here, okay? The first line is PL1 and then PL2, the second budget line. So what happens here? Of course, an increase in income shift the budget line outward in a parallel fashion here, okay? And then here, the second one here, a decrease in income shift the budget line inward in a parallel fashion. This is here, okay? As you can see, this is shift inward. This is shift inward here, okay? Shift inward. Now, also a change in the price of X or Y can, of course, affect the budget line. Affects the budget line. So now we have already understood that a change in income affects the budget line. An increase in income will shift the budget line outward in a parallel fashion. A decrease in income will shift the budget line inward in a parallel fashion. As you can see in these pictures here. Here you have increase and here you have decrease. Now, a change in the price affects the budget line. Thus, an increase in the price of one good. Okay, an increase in the price, of one good moves the intercept on that good's axis toward the origin. As you can see over here. Here, as you can see, what happens here? Increase. Okay, the price of the price of X increases. When it increases, it will do what? It will, moves the intercept on that goods axis toward the origin. As you can see here, the price of X increases, okay, from X1 to X2, and therefore, what happens? The budget line, this is the original budget line, it shifts to here, and this is the PL2 is the final budget line. So it shifts inward toward the origin. Now, conversely, a decrease in the price of one good, we're talking about, we just give the example of the good X, okay? A decrease in the price of one good, here we're talking about good X, would move the intercept on that goods axis away from the origin. So if we decrease the price of X from, PX1 to PX2, decrease the price from PX1 to PX2, of course, what happens? The budget line will, of course, shift, of course, or move the intercept away from the origin. Move the intercept away from the origin. The intercept will get larger from here. This is the I over PX1, and now it becomes, of course, I over PX2. Why? Because PX2 is less than PX1. So when the price of good X decreases, what happens? And income and the price of the other good are the same, then what happens? The budget line, of course, will move, or the intercept of the the budget line, the intercept of that good will move away from the origin, as we see over here. Now, of course, we will present other concepts in this chapter. We see indifference set. Okay, indifference set is a group of baskets that give, of course, group baskets of two goods, that give the consumer equal total utility. Like, for instance, over here, this is a group of baskets, basket A, B, C, and D. Of course, these, of course, are here along this indifference curve, and they give same level of utility, equal level of utility. Okay? Now, indifference curve is a curve or a line that is based upon the indifference set. Okay? Of course, it shows all the basket of two goods that give the consumer equal total utility. In other words, the consumer, is indifferent between all those baskets. It's indifferent. That is, the consumer, this is an indifference curve. The consumer is as happy at A as at B, as at C, as at D. Okay, so therefore he is indifferent between all these baskets. So this is an indifference curve. Okay? Of course, this figure here shows an indifference curve where the consumer is indifferent between all the baskets along the indifference curve, between A, B, C, and D. So the consumer is as happy at A, as at B, as at C, as at D. So he is indifferent between, these baskets. And this is an indifference curve. Of course, an indifference curve, has certain characteristics. What are those characteristics of indifference curves? So the first characteristics, number one, of course, is that they are downward sloping from left to right. Remember that the assumption that a consumer prefers more to less, or more is better for the consumer, dictates that the indifference curve is downward sloping from left to right. Of course, more simply, indifference curves are downward sloping because a consumer uh, has to gain more of one good to maintain a certain level of utility when he gives up more or some of another good. So that shows that the consumer, of course, or the indifference curve is downward sloping. Okay, is downward sloping. If you look at these three shapes of lines, those shapes, don't represent indifference curves, because, as I said, indifference curve, of course, should be downward sloping from left to right. Okay, and therefore the consumer is indifferent between all those baskets along the curve. If you take this, shape over here, where you have a vertical line, it consists of two bundles, A and B. B consists of more units of Y and no less units of X. Therefore, B is preferable to A. And so the consumer cannot be indifferent between A and B, would not be indifferent between A and B. Therefore, this, won't, constitute an indifference curve, because an indifference curve means that the consumer is indifferent between all the baskets along the indifference curve. But here, B is preferable to A, and therefore, a vertical line, cannot be an indifference curve. If we look at this horizontal line, in this horizontal line, it consists of two bundles, A and B. As you can see, B has more of good X, more units of good X, and no less units of good Y. Therefore, B is preferable to A. And therefore, the consumer would not be indifferent between A and B, and therefore, a horizontal line cannot form an indifference curve. Because an indifference curve means that the consumer is indifferent between all baskets along the curve. Here, no. Here we have B is preferable to A, therefore the consumer would not be indifferent between A and B. What about this upward sloping line? In this upward sloping line, we have two bundles, A and B, and you can see that B has more of both goods, has more units, more of Y and more X than A. Therefore, B is preferable to A. And so the consumer, would not be indifferent between A and B. Therefore, an upward sloping curve, cannot be an indifference curve. Now, the second, of course, in characteristics is that indifference curves are convex to the origin. They become flatter as we move, down and to the right along the indifference curve. Look over here. This is an indifference curve. This is, is convex to the origin. Is convex to the origin. Its back is, opposite to the origin. And as we move, down and to the right, or along the indifference curve, it becomes flatter. It flatter means that in absolute value, the slope at point A is higher than the slope at point B, is higher than the slope at point C, is higher than the slope at point D. So this is a flatter curve. Okay. So along, the indifference curve that is, convex to the origin, we can see that in absolute value, the slope at point A is higher than the slope at point B, and the slope at point B is higher than the slope at point C, and the slope at point C is higher than the slope at point D. Also notice that at point A, at combination A, the consumer has more units of Y, okay, and therefore he is willing to give up more to gain an additional unit of X. and thus move to point B. At point B, he has, more, at point B, as you can see, he has 5 units of Y and, of course, 4 units of X. So he is willing to give up 2 units of Y to gain an additional unit of X to move to point C. So at C, he has 3 units of, Y, okay, and 5 units of X. So he is willing to give up 1 unit, of Y to gain an additional unit of X to get to D. In other words, the more a consumer has of one good, the more he is willing to give up in order to get, additional units of the other good. The third, of course, characteristics of indifference curve is that indifference curves are farther from the indifference curves that are farther from the origin are preferable because they represent greater baskets of goods. If you look at this, indifference map. Indifference map, it means that we have many indifference curves. But look over here. The farther the indifference curve from the origin, the higher the total utility, it has. The farther the indifference curve, lies from the origin, the higher total utility it has. If you look over here at, combination B and A, B, as you can see, has more of Y, okay, and no less of X as A. Okay, you have combination A here, you have A over here, okay, and you have B. And as you can see, at B, okay, we have more, or combination B has more units of Y and no less units of X as A. Therefore, B is preferable to A. And because B is located at indifference curve 2, therefore, that indifference curve, which is, above the indifference curve IC1, is preferable to IC1. So in other words, the indifference curves that are farther from the origin, are preferable because they represent a greater basket of goods. Okay? Okay, now the fourth characteristic is that indifference curves, indifference curves cannot intersect. Okay, let's prove this. Okay, here we have 2 indifference curves that intersect. And is that right? The question is that, do indifference curves intersect? Let's prove that, this will cause a logical inconsistency. For instance, here they intersect at point A. As you can see, B is on indifference curve IC1. B is on indifference IC1, but B is located, of course, is the northeast of C. So B is located in the northeast of C. Therefore, as you can see, B is preferable to C. Okay, which implies is preferable to C. B is preferable to C. So what that means? It means that IC1, of course, is preferable to, B, it means here B, of course, is located to the northeast of C. Therefore, B is preferable to C. But B is located what? On IC1. Okay? And C is located on IC2. Therefore, IC1 is what? Is preferable to IC2. Here, IC1 preferable to IC2. It's the first case. Now look at here. D is located to the northeast of E. So D is preferable to E. But D is located on IC2. And E is located on IC1. Therefore, IC2 is preferable to IC1. IC2 is preferable to IC1. This is preferable. This sign is preferable to IC1. And here we see IC1 is preferable to IC2, and IC2 is preferable to IC1. And that is a contradiction. This will cause a logical inconsistency. Okay? Logical inconsistency. In other words, we have a logical inconsistency. You can't have IC1 is preferable to IC2 and IC2 is preferable to IC1. And that logical inconsistency is because, the two indifference curves intersect. So in other words, we will have logical inconsistency if we have indifference curves that intersect. Therefore, indifference curves cannot intersect. Now, together the indifference curve, indifference map, which consists of many indifference curves, and the budget line show consumer equilibrium. Okay, look over here. This is here you have many indifference curves. That is indifference map. And you have the budget line. So, consumer equilibrium will be located, at the point of tangency between the budget line and the highest indifference curve. Here, the point of tangency is at point A at IC2. This is the highest indifference curve that the budget line will reach. So, this at point A, where is the point of tangency between this budget line here and the indifference curve IC2, will show or will give us a consumer equilibrium. In other words, consumer equilibrium, where the consumer maximizes his total utility, is established at point A, at the point of tangency between the budget line and the highest indifference curve, which is IC2. Now, at this point of tangency, it means that the slope of the budget line is equal to the slope of the indifference curve. The slope of the budget line is what? Is Px over Py, the price of good X over the price of good Y. Of course, price of good Y. And the slope of the indifference curve is what? Is margin utility of X over margin utility of Y. So put them together, as you can see. Margin utility of X equal margin utility of Y, which is the slope of the indifference curve, equal Px over Py, which is the slope of the budget line. This is what? At point A. Or, if you play with this formula, we come up with margin utility of X over the price of X is equal margin utility of Y over the price of Y. This is the formula we learned, just previously while discussing other concepts in this chapter. This is the margin utility per price, or margin utility per dollar, are equal for all goods. That is, the margin utility of X over the price of X is equal margin utility of Y over the price of Y, which is the formula we learned just a while ago, which is the equalization of margin utility per dollar for all goods. Here we have good X and good Y. So here, as you can see, at point A, the point of tangency between the indifference curve, the highest indifference curve, and the budget line will give us consumer equilibrium.